Hey, hi friends. Very good morning to everyone. Before we start with today's session, so anyone having any questions with respect to the last class? Okay, so I'll take that as no. So let's start with today's session. So today we are going to see the internals of user connectivity, like how the user will connect to the database and what happens internally during that time. So let us take an example for that. So user connectivity to the database can happen in two ways. One is from a remote machine and one is from the database server itself. So let me just now try to show you that. Okay. So assuming I have a database server which is hosted on some machine, and then I have a user desktop. So in this user desktop, let's say an application was installed, and in that application, when that particular user open that application, it will ask for the username and the password. So those details need to be entered. So once the detail has been entered, it will try to connect to the database server with the help of that username and password. So this is what we call it as a remote connectivity. So remotely, the user will be existing and that user will try to connect to the database. So this is one way of connecting. Second way is on the database server itself. Sometimes we will be installing the application as well. So which means this is going to act in a dual mode. So that server itself is the application server or that server is the database server. So in that case, the users will directly log into this server. So using some tools like for example Putty, and once they log into that server, they will be using command like SQL plus then username and password. Then it will connect to the database. So more about how this configuration will happen, we will discuss during networking. But just to give an idea, different types of connectivity that are possible. One is a remote connectivity and the other one is a local connectivity. So either it is a remote connectivity or it is a local connectivity. Uh, of course, you need to provide the username and password. After that, what will happen in the database? We are going to see that now. So when like taking an example of remote connectivity, because that is what will happen most of the times in real time. So let's say, as I said, this is the user's desktop and the user has opened an application where it is asking for the username and then password. So two fields are there. So the assuming user has entered the details, like for example, the username as Scott and the password as the tiger. So after entering these details, how the connectivity will happen to the database. Before that, when user starts this particular application, in the background a process will start, which we call it as user process. So, and any process, do remember, will occupy CPU and memory. So this we can see, to give an example, we can see this in the task manager. So if you take a look at here, the task manager. So here, for each and every application, there is a background process involved. So this background process, if you look at here, it is consuming some CPU in this column, and it is also consuming some memory here. For example, Firefox is consuming 0.3% of CPU as of now, and it is consuming 830 MB of memory out of my entire RAM. So similar to this, when this user has opened any application, so in the background it will create a user process, and that will consume some CPU and memory. So that once the details has been entered, now these details will be received by the database server, and in the database server we have a component called listener. So this component is going to grab the information, like whatever the username password details that were being sent by the user, so those details will be received by the listener. So listener, we can understand, is like a door to the database. So just like how you have a main door to enter into your house, similar to that, to enter into the database, we need to have a listener. So what this listener is going to do, listener is going to hand over this information to one of the background process called process monitor, or shortly we are going to call it as PMON. So if I show you in the architecture diagram, here it is. So listener is going to hand over to this particular background process PMON. Now PMON, what it is going to do, it is going to uh, verify the details, like authenticate the user, whether user has given the correct username or correct password or not. Now how PMON knows that information, like how it knows that Tiger is the password for Scott user, or some X is the password of Y user, how it knows that. So all that information will be stored in the database. So in the database, we have different files here. So one file is called data files. So in that files, we are going to store this information, like what is the username and password in a particular table. We call that as base table. So the table name would be user dollar. So in this particular table, we will be having the information of what are all the users created in the database and what are their passwords. So what PMON is going to do, now here, that the operating system will concept will come into picture, like yesterday what we discussed. So first it is going to check for this information in the instance. So that is what yesterday we understood. Any request, first the information will be searched in the instance. If that information is not available, then it will be picked up from the database. So what PMON will do, here we have a component called shade pool in the architecture, and the shade pool is again divided into two subcomponents. One is library cache and the second one is data dictionary cache. So this is what I am talking about. So what PMON is going to do, the moment it receives the information about the username and password from listener, it is going to first travel to data dictionary cache, and it will see whether a copy of this user dollar table is already there in the instance or not. Like the same way what we discussed yesterday, when a select query was issued, first the information will be searched in instance. If it is not there, then it will is going to pick up from the database. So similarly, here Pmon also will first search in the instance for this user dollar table, and if the table is not available, then it will come down to database. As I said, in database we have a component called data files. Under that we will be having this user dollar. So it is going to copy that table from the data files to data dictionary cache. So same like as we understood yesterday. So if the information is not readily available in the RAM, so we know that operating system is going to copy that data to RAM. So similar to that, here also it will copy the data to data dictionary cache. And after that, it is because now the copy of table is available in the memory, so it is going to Pmon is going to perform the authentication. So authentication is nothing but whatever the username that user has given and whatever the username that the table is having are matching or not. Similarly, whatever the password user has given, whatever the password the table is having are matching or not. So these are the things that it is going to check. And if it is a successful authentication, means the username and password are matching, or if it is a failed authentication, means something is wrong with the credentials. In both of the cases, Pmon is going to send an acknowledgement to the user process. So either this acknowledgement could be a successful acknowledgement or it could be a failed acknowledgement. So if it is a successful acknowledgement, user will see SQL prompt, means it is connected to the database. The user is connected to the database. If it is a failed authentication, then user will get a message like this: invalid username or password. So in this case, user need to, if it is a failed authentication, user need to retry with the correct username and the password that we know it already. Now, if it is a successful authentication, after Pmon sending this acknowledgement, Pmon is going to create one process on the server side, which we are going to call it as server process. So, and this server process is going to help the user process in in the next coming things, like for example, after connecting to the database, this user process has issued select query, so that select query will be actually processed by this server process. Or this user process has issued some DML statement, so the DML statement in the database will be executed by the server process, or DDL statement that will be also taken care by server process. So which means you are basically giving the input, but the response but the processing and all will be done by the server process itself. So we say this server process is uh, a friend of user process which is going to do the actual work. And as I said, each and every process will have a CPU and memory consumption. Like user process will have that, and Pmon will have that. Pmon also will consume some CPU and memory, and even server process also will consume some CPU and memory. but the memory occupied by server process has been given an exclusive name, that is PGA. So you will be able to see that in the picture. So for every process, like user process also will consume memory. All these background process also will consume memory, but exclusively for server process, the name was mentioned here, PGA. So we will discuss, gradually further what is this PGA, why Oracle has given importance to the server process. So we will see those things. But as of now, you can remember this. So this is what will happen during user authentication. So let me put again. So first the user will provide the details like the username and the password, and through some application, and the background of the application we will be having a process which we call it as user process. So this information will be received by a component called listener, and this listener is going to hand over the information to Pmon. Pmon is going to first check for that information in the data dictionary cache, that is in the memory. If the table is not available, then it is going to travel down to database, and it is going to search in a component called data files, and it is going to put a copy in the data dictionary cache. After placing the table copy, it is going to do the authentication, and either if it is successful or failed authentication, Pmon is going to send the acknowledgement to the user process. So if it is a successful acknowledgement, then Pmon is going to create one more process on the server, that we call it as server process, which will do the actual work on behalf of the user process. And the memory that is allocated to the server process is called as PGA. Later we will see what are all actions will be done in the PGA. And if it is a failed authentication, of course, the responsibility lies with the user. So user need to provide the correct username and the password. So once this connection has been established and server process has been created, then you won't see listener anymore. So it's like, as I said, listener is like a door to enter to the house. So the moment you are already entered into the database, you don't have any work with your listener, because already you are there in the database. So that is the reason in the architecture diagram, I have not shown that particular component, assuming that user is already connected to the database. So this is how it will be. After connectivity, user process will always in talk with server process, and as I said, server process is the one which will actually do the work in the database. So anyone having questions? So that that is about the user connectivity. Now during this time we talked about one component called base tables. So we need to understand what is mean by these base tables. So any information with respect to the database will be stored in these base tables. So there are user tables and there are base tables. Now what is the difference here? For example, you executed some command like select star from EMP. Now you know that EMP is a table, but how Oracle will know that EMP is a table? Or you have given some name like select star from profit. So how Oracle database will know whether this name, I mean, by the name that it is a table or it is a view or it is a synonym. It could be anything. So how Oracle knows that information? It is going to store all this information in some of the tables. For example, we have a table called obj dollar. So in this, Oracle is going to store the information like who is the owner and what is the object type. So if you take for example profit, it will store like, let's say owner is Scott and the object type is synonym. Let's say that's not a table, that is a synonym. So in that case, because we know that synonym is created on top of a table or a view. So next we have another base table, synonym dollar. So in this table, it is going to again store the information, who is the owner of the synonym, then what is the name of the synonym, and who is the owner of the table, and what is the table name. So this information will be stored in synonym dollar. Suppose this is not a synonym, this is a table. Then that information will be stored in another base table called tab dollar or table dollar. So here also again it will store some information, who is the owner, what is the table name, then etc etc, all that information. So which means for each and every object it is going to store some information in the uh, tables, and these tables we are going to call it as base tables. Now one common thing if you observe here, all the base tables are ending with a dollar sign. So that is the standard what Oracle will follow. So when you are searching for something in the database, if you see that any table with a dollar sign ending with a dollar sign, then do remember it is a base table. So here you can see that base tables are the components which will store the information of the objects or users, anything, and this will be helpful in the database operations. And this can be also called as a dictionary information. So just like how we'll be having what you say metadata information for a table, so this is also something like that. And as I discussed, it is in the form of some name followed by the dollar sign, and it will reside in something called system table space. We have not yet started discussing about table spaces, so later you will understand about it. And the information in the base tables will be in cryptic format. Very important point to remember. So if you directly say select star from tab dollar, let's say from here, so you will not be able to see any information in human readable format. Why? Because the information is in cryptic, so it is encrypted basically. So only Oracle processes will have the authority to either create, delete, or modify the base tables. So manually, we should never attempt to directly execute any DML or DDL commands into these base tables. So I cannot run any insert statements or delete statements or update statements or any DDL like create, alter table, truncate table, etc. So I should not run any of these commands against the base tables. So it is only the responsibility of Oracle background processes. And when the base tables will be created, the base tables will be created during database creation, especially with the help of a script called sql.bsq. Now the question here is, if the information inside the base table is in cryptic format, how it will help me as a DBA? Because as a DBA, it is expected that we should have access to all the information. So for example, let's say your client asked the information how many users are created in the database. So whatever the user you create, that information will be there in this base table user dollar. So your client asked to know how many number of users are there in the database, created in the database. Now if this information is cryptic, how I will get that information? So for that, Oracle has created two types of views. One is called as data dictionary views, and the second one is called as dynamic performance views. So data dictionary views will give you the static information or the permanent information of the database. I don't say it as permanent, but it is a static information. Whereas dynamic performance will give you dynamic information in the database. Now what is mean by static information and what is mean by dynamic information? So, so let's say your client has asked two queries. One is how many number of users are there in the database, and number two, how many users connected right now. So if you look at here, both the queries are different. Here they are talking about the number of users created in the database, which is a static information. And here they are asking about how many users connected as of now. So this is a dynamic information. Why? Because this moment you may have 30 users connected, and the next moment or the next minute it may increase to 40, or the very next moment it may come down to 15. So users will keep on connecting and disconnecting to the database. So this information is dynamic. Whereas the number of users created in the database is static. So that static information you will be getting from data dictionary views, and such kind of dynamic information, how many users connected and all, will be retrieved from this dynamic performance views. And these views are again, I mean, just like how base tables are represented with a dollar sign at the end of the name. Similarly, in the beginning of the name, these views will be having a DB underscore. So for example, if you want to retrieve the number of users information, then you need to query a view called DB underscore users. So always the name will be prefixed by DB underscore. Similarly, if you go with the dynamic performance views, it will be prefixed with V dollar. V dollar followed by some name. So for example, in our case, we need to get the information on how many users connected right now from a view called V dollar session. So DB underscore views will give you the static information, whereas V dollar views will give you the dynamic information of the database. So those are the points mentioned here. So about data dictionary views and dynamic performance views. Again, these views will be created with the help of a script called catalog.sql. And along with these views, Oracle has given us some packages and procedures as well, PLSQL packages and procedures. So those packages and procedures also will be created with the help of another script, catproc.sql. Now, when you are creating this database, there are two ways to create the database. One is using a tool, or one is using a script manually. So if you are using a tool to create the database, automatically the tool will execute this catalog and catproc scripts. But when you create a database manually, then manually you need to execute both the scripts. So anyway, in our practicals, we will be seeing both how to create database using a tool and how to create a database using manual method. But you just need to remember this point. and these scripts will be located in a specific location called Oracle Home DBMS admin, where Oracle Home is the location where you are installing Oracle software. Like for example, if you take a Linux operating system, uh, during the installation you might have seen we are creating mount points like U01, U02, U03, etc. So let's say under U01 I have created some directories, like let's say slash U01 slash Oracle slash 12c. So I have created these two directories inside it. So, and I am installing my software in this location. Then this will automatically become my Oracle home. So after I install the software, under this location, I will be getting two more directories. One is RDBMS, and under that I will be having one more directory, that is admin. And in that admin directory, we will be having these two scripts. We will be having lot many scripts, but these two scripts also will reside in the same location. So that is about the base tables and the views what we have on the base tables, how they are going to help us. So anyone, any questions? Okay, so let's proceed with the next thing, that is phases of SQL execution. So we are going to talk about how a select statement will process in the database, or when you say select star from EMP, how the data will be retrieved from the database. So before going for that, we need to understand in which phases that SQL statement will go through. So those phases we are going to discuss now. So just give me a moment, I'm getting a phone call. Okay, so that is about the things. So let's move on to the phases of SQL execution. So any SQL statement, either it could be a select statement or DML or DDL statement. So it will basically go through these three phases. So the first thing we are going to call it as parsing. So during parsing, again it will undergo three subphases. One is of course syntax checking. You know that every language will have a standard syntax. So just like that, even SQL language is also having a syntax. So that syntax checking will be done when you submit a statement. And then semantic checking will happen. So semantic checking is nothing but checking the privileges with the help of the base tables. So what exactly it mean? So let's say I connected as user Pawan and I have issued a statement select star from EMP. So what will happen now? So the moment you submit this in semantic checking phase, as I said, Oracle need to get the information what is this EMP is. So it will go to obj dollar and it will check what is the object type of this EMP. Then it will get to know that EMP is a table. So because EMP is a table, Oracle will come down to the next base table, that is obj dollar, and it will identify who is the owner of this EMP table. Then it will come to know that the owner is Scott. Now the owner of the table is different from the user which I have connected. So if I have connected as Scott user, then the data can be retrieved and can be given to that user. But I have connected as Pawan user, but I am retrieving table in Scott user, which means Pawan should have privileges on the EMP table. So until unless the privileges are there, you should not give the data. So for that you need to check for the privileges. So that will be done in two views, either in object authentication or privilege. So in this it will identify, it will check whether Pawan is having access to Scott tables or not, or especially to this EMP table or not. If this information, or if let's say here it got that it got the output as true, means yes, Pawan is having the authentication or Pawan is having the privilege to access EMP table, it will proceed further. So it will go to further base tables like column dollar, where it is going to retrieve how many columns are there in the EMP table. So then it will follow another base table, that is index dollar, wherein it will check what are all the index there on this EMP table. So then constraints. So like that, it will touch so many base tables. But if it is a false, let's say, then user will get a message that insufficient privileges. Means you don't have authority to access this EMP table. So this is what will happen during semantic checking. So it will touch so many base tables and to retrieve the information and all. So this we will be seeing practically during performance tuning. I will show you, how this semantic checking will happen. Hope everybody got to know what is mean by semantic checking. So once it is done, then the statement will be divided into literals, or we call that as a parser tree. So what exactly mean by this? Here if you look at, I have given an example. So there is a select statement here on the top. So once the select statement has been divided into literals or been parsed, how that statement will look like, bottom you can see. So basically each and every clause and each and every object name or the conditions will be divided. For example, select is separated, from is separated, where is separated. Again, in the select, what are all the columns I am selecting, that is separated. Table names are separated. Then again, in where condition, we have two where conditions. So one is, both are joined together on that AND operator. So that will be divided. So like this, all the components will be separated in the SQL statement. So that we call it as parser tree. So that completes the parsing. Then the next phase will start, that is execution. So execution also again retrieved in or it can be done in three phases. One is converting the statement into ASCII format. So if you say select, Oracle will not understand what is meant by select. So this statement need to be converted into ASCII format. So just like we know, computers will understand only binary language. So whatever you do, internally it will be converted into the binary language or assembly language. Similar to that, here also the conversion will happen to ASCII format. So once it is done, it will be again compiled and then finally the statement will be executed. So the moment the statement is executed, then it will understand that I need to retrieve the data from so and so table, and for that it is going to perform the fetching. So while performing the fetching, that is pulling out the data, again it will follow the operating system concept. So first it will check whether the data is readily available in the instance or not. Let's say EMP table data. So it will check whether EMP table data is ready in the instance or not. So we have a component called database buffer cache. So in that it is going to check. If it is not there, it will come down to database. Then it is going to retrieve the data and it is going to place a copy in the instance. So that we call it as fetching. So if the data is readily available in the instance, we call that as a logical read. If the data is not available in the instance and you are retrieving from the database, that is called as physical read. So in logical read, there is no IO involved, but whereas in physical read, IO is involved. And more number of IOs you do, it is going to impact the performance. So the more number of IOs, the less performance, or less number of IOs, more performance. So that is what will happen here. And the same point, as I said, retrieving the data from the instance is called as logical read. Some other terms are also there, like the buffer read or buffer get, or if it is a physical read, we call that as a disk read or buffer miss. Now, how the data inside the database will be stored? Inside the database, it will be stored in the form of blocks. So when I say blocks, it is something like this. So I have my rows, whatever the table rows that are there, so they will be stored in the form of a block like this. So like this, I will be having blocks in the database. So each and every block will be having the table data. So depends on the size of the block, the data storage also will change. For example, the standard block size is 8 KB. Now, if your table data is occupying less than 8 KB, then one block is sufficient to store the data. Let's say I have one table by the name T1. It is occupying 3 KB. Obviously, not even half of the block is required. I can have my data stored like this. Then let's say I have another table which is again occupying another 3 KB. So that will be also fitted here, which means one block contains two tables, T1 and T2. Let's take another situation. I have a table T3 which is having a size of let's say 40 KB. So obviously one block cannot be when one block cannot be fitting all the data, because we can store only maximum of 8 KB data. So I would be requiring multiple blocks in such case. So here all these blocks are going to occupy the same table data. So which means either one block can hold multiple table data, or one table data can be spread across multiple blocks. Depends on the size of the table. So that is what was given the point here. Okay, so if it is a PLSQL program, like what we discussed is a SQL statement. Suppose if you are having a PLSQL code, then there will be an extra phase called binding. So parsing, binding, execution and fetch. Four phases will be there. If it is not a PLSQL program, it will be only three phases. So that is what will happen uh, during this SQL execution. Those are the phases what we have. So anyone having any questions?
What is binding?
Sorry, can you ask the question again?
What is binding?
My view,
Binding.
I'm not getting your voice correctly. Binding, you mean to say, okay, this one.
Yes, that's the one. Yeah.
Okay, so basically, when we write PLSQL programs, you will be passing on the variables. So, like in the program, it would be something like you will be putting down the variable values like this, B1, B2, or you might be declaring something called cursors. So, cursor is like temporary memory area wherein you are going to store the data. So, what will happen is the value what actually you are passing will be binded together with the variable.
Okay.
So
Okay.
to give an example, let's say in the query you have given something like where department number is equals to B2, and in the application when user is entering the data, they have given the value as 10. Then what happens? This department number is equal to 10. So this is binded together. So we call that as binding. So got that point?
Yes, got it. Thank you.
Okay. So any other questions from anyone? Okay, so let's move on to the next thing. How a select statement will process in the database. So let us have a look at that. So here, so many components will be involved during this process. So let us try to understand that. So the first thing is user process will issue the statement. So if you recollect the architecture, we have user process here. So user process will issue the statement. Then server process will receive the statement and it will send to the library cache of shared pool. So server process will receive that statement. As we already know, server process is having a memory area called PGA. So server process will send this statement to shared pool, and in shared pool we have two different components. One is library cache and the second one is data dictionary cache. So server process will send the statement to the library cache. Now in library cache, the first phase of SQL execution, whatever we talked about, parsing will takes place. Now for the very first time, server process requires this base tables to be copied in order to perform the semantic checking. Let's say just now I started my database. So when we start the database, because instance is memory, and you know that memory is volatile, nothing will be there in the instance. So the very first time, when the statement is submitted to this library cache, as we are saying, parsing will happen. Now, parsing is divided into three phases. One is syntax checking, one is semantic checking, and then dividing the statement into literals. Now, to do semantic checking, just now we understand that we require base tables. And where the copy of base tables will be there, it will be there in the data dictionary cache. So what we are saying is, when the very first time you issue this statement, there will be no copy of base tables in data dictionary cache, because just now we started the database. So in such cases, the base tables will be retrieved from the database by this server process, and it is going to copy all the base tables here, like tab dollar, obj dollar, etc., etc. So after copying those base tables, then it will start the semantic checking. This is for the very first time. So next time onwards, already because the copy is readily available in the data dictionary cache, directly it can go for semantic checking. Now once this parsing is completed in library cache, then in the library cache itself, we have a component called optimizer. So this optimizer component is nothing but basically an algorithm that Oracle has developed. So this optimizer is going to generate some plans of execution. So what exactly it means? So we call them as execution plans. So it will tell this is user process and this is EMP table. So this user process wants to reach the EMP table, then there are different uh, ways to go. So which means, just like in Google Maps, if you place your source and destination, how you will get different directions or different routes to reach your destination. Similarly, here also you will get different, directions. So, and each one we are going to call it as execution plan. And each and every execution plan will have a specific ID. ID in the sense some value, unique value will be there. So for example, let's say execution plan ID 1 is saying that, so if you follow plan number 1, you will be consuming 30% CPU and you will be consuming 40% of memory, and you will be retrieving the data in 3 seconds. Let's say this is the plan briefness. So by consuming 30% of CPU, 40% of memory, you can able to retrieve the data in 3 seconds. That is plan number 1. Plan number 2 says, if you consume 60% of CPU, if you consume 50% of memory, you can able to retrieve the data in 1.5 seconds. That is another plan. Plan number 3 says, if you consume 90% of CPU and if you consume 80% of memory, you can able to get the data in zero point 0.5 seconds, that is half second. Like this, optimizer is going to generate multiple plans and it will give that plan to the server process. And not only it is going to generate multiple plans, but the optimizer itself will choose which is the best one. Now if you take a look at here, out of these three plans, the first plan is consuming 3 seconds, which we may assume that it is a little bit higher. I mean 3 seconds is a long duration when compared to the processing. Now when you go with plan number 3, even though we are getting the data in only half a second, but CPU and memory are utilized to the max, like 90% of CPU is utilized and 80% of memory is utilized. So if, for example, this user itself is using 90% CPU, how about other users? Because you are not the only user connected to the database. There will be other users as well. So optimizer need to do justice to the other users as well. So that is the reason it will go with plan number 2, which is reasonable. So you are consuming a little bit CPU as well as memory, and as well you are getting the response in uh, minimal time. Out of these three plans, we may consider, or optimizer will say that plan number 2 is the best one. So by taking this plan number 2 from this library cache, server process will come down to PGA. So before proceeding further, is these points clear? What is meant by optimizer and what exactly it will do? Because it's much more important to understand. Okay, so let me put it again here. So user process will issue the statement, server process will receive it, and it has sent the statement to library cache. Parsing will takes place, then optimizer will generate many plans, but it will choose the best one. So by taking that plan, it is the server process is going to come down to PGA. So those are the things that happens. Next, in PGA, whatever the phase we called about execution will takes place. So parsing will takes place in library cache, execution will takes place in PGA. So what is meant by execution? Uh, we understood that like converting the statement into ASCII format, then compilation, and then actual execution. So these three things will happen here in the PGA. And once it is done, then we are having the next phase, that is fetching the data. Now fetching the data is again two ways. One is, first it will try to fetch the data from the instance itself. So that will be happening in a component called database buffer cache. So database buffer cache is again divided into two components. One is called as LRU list and the second one is called as write list. So let me show you the diagram once again. So this is the one I'm talking about. So this is the component database buffer cache. So it contains two components. One is LRU list and the second one is write list. So our server process is going to search for the data first in the LRU list. because that is the place where we will have copy of the data. So let's say we are retrieving EMP table data. So server process will check in this LRU list whether I have EMP table data or not. Now how the data will be there in the LRU list? It will be there in the form of blocks. So server process will scan all these blocks to verify whether I have EMP table data readily available or not. Now let's say the data is not available. Then because the data is not available, similar to operating system concept, server process will come down to database. It will check for the EMP table data, and it is going to place the TMP table data at the top of the LRU list. And this top portion of LRU list, we call it as MRUN, and the bottom portion of LRU list, we call it as LRUN. So MRU in the sense most recently used, means the data which you are accessing currently is called as most recently used, whereas the data which you are not using since long time, that will be called as least recently used. So the data, whatever it is retrieving from the sorry, the data whatever it is retrieving from the database, it is going to put the data in the form of blocks. So how the data will be retrieved, as I said, it will be stored in the form of blocks. So these blocks will be copied to MRUN. So once the blocks are copied to MRUN, there are two things. Now, if that blocks contains only EMP table data, then directly that data will be given to the user process. But as I said, not always one block contains one table data. Sometimes it might happen that one block may contain two tables data. Suppose in one block I have both EMP table data and DEPT table data. Now if I give this block to user process directly, it is wrong. Why? Because user process asked for only EMP table data, but I am giving DEPT table data as well. This is wrong. So if you have such kind of situation that a filtering is required, then these blocks will be copied to PGA again. If filtering is not required, directly the data will be given to the user process. But if filtering is required, it requires the filtering, then these blocks will be copied to PGA, and in PGA the data will be segregated. So if I have two tables data like this in PGA, it will take only EMP table data, and then it is going to give to the user process. So here the processing of filtering will happen, and then only the filtered data will be given to the user process. So this is how a select statement will process in the database. So first user process will give the statement, server process will take the statement and it will send to library cache, parsing will happen, optimizer will come into picture, it will generate many execution plans, but by itself it will choose the best one. So by taking that best execution plan, server process will come down to PGA and the execution will take place there, and then server process will start searching for the data in the LRU list. If the data is not present in the LRU list, then server process is going to come down to database and it is going to pick up the data and it is going to place it MRUN of LRU list. If the block is not requiring any filtering, directly the data will be given to user process. But if it requires filtering, it will be again copied to PGA, and in PGA whatever the required data is there, that will be filtered out and that will be given to the user process. So this is what will happen during the processing.
One question. I was not aware, like, okay, a block can share two tables data.
Yeah.
Okay.
Yes, Sachin. I mean, is that the question you are asking? Can a block will share?
Yeah. Because I was under the impression when you said it will read from the hard disk. You can read a block and it will copy that block to the buffer cache, data buffer cache, right?
Mhm.
But suppose how will it copy the two tables data, right, into the same block? Because
That
it reads block by block from the hard disk itself, right? So first it will get the block
mm,
from the hard disk, right? And it will copy to the data buffer cache, correct?
yeah, right. From the hard disk, it is going to copy the data block onto the LRU list.
Yes. So then when will this happen? Like, how come a block will have two tables data?
That is when you are already inserting the data. So this is when we are talking about selecting the data, but we didn't discuss about writing into I mean performing an insert or something. So tomorrow we are
Okay.
going to look at how a DML will process. Then you will understand that.
Okay. Yeah, that's fine.
So any other questions from anyone?
Pawan, what is LRU and what is the use of that?
Yeah, we will discuss that. Uh, anyway, like we need to see about those components. So I will let you know. Okay, so now for this is assuming, for the first time or something. Now when you go with the same statement second time, let's say, generally, in SQL window, you can say slash and enter. When you say slash and enter, it means that you want to run the same statement again. So like that, or some other user also issued the same select star from EMP table, I mean EMP query. Then what happens is for the second time, so let's say it is a different user and different server process is there. So this server process also will send the same statement to library cache. But already the statement is parsed. So in library cache already the statement is parsed and optimizer also generated the plans and best one is already available. So that is why server process will straight away, I mean, it will skip the parsing, library parsing and optimization will be skipped, and straight away server process will come down to its own PGA with that best execution plan, and it will be executed here, which means you are skipping parsing here. Once the execution happens, again it will start searching for the data in the LRU list because the data is already copied by some other user or some other server process already. So this data is readily available in LRU list. So you can directly get the data from the LRU list itself. So which means you are not performing the complete fetching, which means you are avoiding fetching as well for the next time I am saying. So which means from the second time onwards, you are avoiding both the parsing as well as fetching, which is going to obviously reduce the response time. So the very first time you have taken, your statement has taken 1.5 seconds to retrieve. From second time onwards, it will take only half a second to retrieve the data because the processing and all is already done. Now when this is in 10G architecture, In 11G architecture, when we come to that point, you will be seeing even execution also will not happen, and directly you can fetch the data. So Oracle has introduced some new memory component for that. So when we discuss about 11G architecture, we will be seeing that. So that is about the select statement processing. So anyone having any questions? Okay, so tomorrow we will continue with the session with understanding about DML and DDL processings.